Okay, so for the kinematic equations, so let's refer to, please refer to the guided practice problems which can be located either on the Canvas or the PowerPoint that is provided to you. Okay, so for the first problem, what are the given? So first we have from rest, so accelerates from rest. Okay, so of course if it's coming from rest, its initial velocity is 0. Okay, then its final velocity according to the problem, so that's v, is 15 meters per second going to the west. Okay, we're going to just use that later. Okay, what's the time? So according to the problem, it's 1.8 seconds or 1.80 seconds. So what is being asked? So these are our given. Okay, for the required, or what is being looked for in this problem is the acceleration. Okay, so pro tip, if you already have the table of the kinematic equations, you can just look at it and make sure that you break down some of the variables if you think that some are missing. Like for example, instead of having delta x, you have x sub 0 and x. So of course you're going to do delta x is equal to x minus x sub 0. So that's for some cases. Alright, so just take note of that. Alright, let's proceed with this. So upon looking at your let's say guide, okay, that would be v is equal to v sub 0 plus a delta t, correct? So if you're going to see, or if you're going to notice, so look at the variables. All of the variables in this equation are present here. So that's how you're going to solve for problems involving excuse me, kinematic equations. So you have v sub 0 here, you have v here, okay, you have delta t here, and you have a here. Okay, next of course we're going to derive. Okay, so this is addition, right? So this must be transposed to the left, so v minus v sub 0. Okay, if always remember, if the operation between the terms, so we call these terms, right, is separated by addition or subtraction, so you can just transpose it. Okay, so dividing both sides apply only if the operation is either multiplication or division. So this is a delta t, correct? And then since we're looking for a, we want a to remain on that side. Okay, so we want it to be alone on that side. Okay. Of course, how can we solve problems if we're not going to isolate what really the problem is, or in this case what we're looking for is a. So divide both sides. So as you can see, the operation between acceleration and time is multiplication. So to transfer time to the other side, you have to divide it. So cancel this because delta t divided by delta t is 1. So of course nothing would remain. So our final equation is a is equal to v minus v sub 0 divided by delta t. Okay, next let's substitute. So you see that it's not really hard, isn't it? 15 meters per second minus 0 divided by, what's our delta t? 1.8 seconds. Okay. So this is the value of a. Okay, so what's a? This is already actually the answer. So let's try to put that on our cycle. So that's 15.0 oops, let's do this instead. Can you see it? 15.0 divided by 1.80. So the answer is there, 8.33. 8.33. How about the unit? So if you're going to notice, this is the unit. If you're going to, I'm just going to take the unit and show you how it should be done. So meters per second divided by second. So that would translate to meters per second divided by second over 1. So this is second over 1, right? So of course, when dividing fractions, what we really want to do is multiply them instead. So that would become 1 over s. You're going to reciprocal this one if you remember that. So this would become meter per second squared, which is correct. This is the unit for acceleration. This is supposed to be the unit of your final answer. So let's place it here. Okay, so always remember that I'm very particular with the units. Okay, cancellation of units or multiplication of units. So missing a unit would of course automatically give you the wrong answer. By the way, this is going to the west. Okay, so of course, because acceleration is a vector. So that's it. There's not much else. Let's proceed to another practice utilizing another kinematic equation. Alright, for the second case, let's have the guided practice problem number 2. So let's write the given. So according to it, steadily increasing your velocity. So you're going to start from a certain velocity, which is 30 kilometers per hour. Okay, and then final velocity is 60 kilometers per hour. Okay, then we have a time which is 30 minutes. Okay, so this is the given of this problem. For the required, this being asked is the distance that you have covered. So that's delta x. Okay, so combining two positions. By the way, always remember that on the kinematic equations, speed and velocity are interchangeable. Then distance and displacement are interchangeable on the problem. Alright, so for the equation, take a look at this, then look at your guide once again, and you're going to notice that the equation for this one is delta x is equal to v plus v sub 0 over 2 times time. Correct? So for the solution, of course, it's not automatically going to that. So first, we need to convert, because as you're going to notice, the unit of this is not in scientific, what do you call this? In SI form. Okay, so it should be in SI. So what's the SI of this? It should be in something meters per second. Same one with here, something meters per second. Then this one, it should be something seconds. Okay, it should be in seconds, not in minutes, because that's not the SI form for that. So let's do that for v sub 0. So this is 30 kilometers per hour, correct? So to convert, I hope you have reviewed on the ones that I placed on the Canvas course. If not, kindly revisit it again to know how conversion should be done. Okay, so I'm not going to elaborate it here anymore. So 1 hour. Okay, how many seconds are there in 1 hour? That's 60 times 60, correct? Kasi 60 seconds in 1 minute, then 60 minutes in 1 hour. So that's 60 times 60. So that's 3,600 seconds. Okay, so these are the same, so divide them or cancel them out. Then this one is the same, so cancel them out. So the final value of v sub 0 is 30 times 1000 divided by 3600. So let's write that on our cycle. 30 times 1000 divided by 3600. See that? Okay, so what's the answer? 8.33, or of course 8.3333, because we want to preserve as much decimal place as possible. Okay, so this would become now 8.3333 meters per second. How about this one? So let's change this. Okay, for V, same process. Okay, so that would be V is equal to 60 kilometers per hour. Okay, times 1000 meters divided by 1 km times 1 hour over 3600 seconds. So, oops, this should be the one which should be cancelled there. Okay, so it's actually just times 2 of this. If you're going to notice, this is 30, then this is 60. But if you can compute it if to be sure, so this would be 16.6667 meters per second. Okay, so this is 16.6667 meters per second. How about this one? For the time, so that's easy. So that's delta t is 30 minutes. Okay, so 1 minute is 60 seconds. So this is equal to 30 times 60, which is 180 seconds. Okay, so this is 180. Alright, you got that? Wait, 3 times 6 is 18. This is 1800s or 1800, sorry. There you go, because we have 2 zeros. Alright, so after that we can now proceed on the solution. So the solution is, what are we looking for? It's delta x, so it's already equated to that, so we don't have to derive anymore. So that's delta x is equal to, so what's our v sub 0? 8.3333 meters per second, sorry, plus 16.6667 meters per second. Okay, still see it? Okay, divided by 2 times time, which is 1800 seconds. Okay, so let's proceed on doing that on the cycle. So you can place it on the cycle as is, but of course be very sure on the cancellation of the units. This is 8.3333 plus 16.667 divided by 2 times 1800. So here, can you see it? There you go. Okay, so what's the answer? Oops, syntax error. Let me check that again. Yeah, here. So what's the answer? 22,500. Okay, so the answer is delta x is equal to 22,500. So what's the unit? So if you're going to add this, add, then this is multiply. Correct? So it's going to happen. So of course you're going to cancel that. So the final unit for this would be correct, because this is on the denominator and this is on the numerator, so cancel this. So you're going to have meters. So if the unit, I mean if the operation is addition, of course the unit will remain the same as long as they're the same. So this is meters. Okay, or you can change that into kilometers. So by moving 3 decimal places, so that's 22.5 kilometers. Okay, both of these are correct. So that's it. Okay, for the third case, let's write the given. So what are the given? We have acceleration, which is 26 meters per second. Okay, we have what do you call this? Accelerates from a speed. So from is initial, of course 2 is the final, from is coming from, 2 is going to, right? So this is 20 meters per second. And then we have a time, which is 5.56 seconds. Okay, for the required, what we need is how far does it travel. Okay, so the distance covered, or the displacement covered, which is of course delta x. So take a look again at your practice table, and you're going to notice that the equation we're going to use is delta x is a delta t squared over 2 plus v sub 0 delta t. Correct? So that's the equation we're going to use. So check the units. They are already in, what do you call this, scientific notation, so there's not much else to I mean in SI unit, so there's not much else to do with that. So let's proceed on the solution. So for the solution, that would be delta x is equal to, so just substitute, so A is 26 meters per second. Okay, correct, times, what's our time, 5.56 seconds, so this is to be squared. Okay, divided by, what's the time, I divided by 2, sorry, so this is plus, so what's our v sub 0, 20 meters per second multiplied by time, so this is 5.56 seconds. Okay, so you're going to notice na if you square it, so you're going to square this one, okay, the seconds, correct. Then from here, this is meter per second squared because this is acceleration. Check that one. So you're going to multiply the units here. So this is meter per second. So this is on the division side. I mean, this is on the denominator side. This is on the numerator side. So you're going to divide them, right? Then next, going to notice that this is second squared, this is second squared, same case here, so you're going to cancel this. So what's left are these values, so let's put that on the cycle, and you're going to notice that the remaining unit is meters, which is what we need. Okay, delta x, so let's put that on the cycle. Can you see it? Okay, can you see it? Okay, let me put it first. 26 multiplied by 5.56 to be squared divided by 2 plus 20 times 5.56. So what's the answer to that? Here, I'm going to show you. Okay, there, can you see it? 26 times 5.56 to be squared divided by 2 plus 20 times 5.56. Oops, syntax error again, let me check. There you go. So what's the answer? There, 513.08. You see that? Okay, so that's the answer. See, it's not really that hard, isn't it? So this is 513.08. What's the unit? This is in meters, of course. Okay, so this is our delta x. So that's the final answer. So I would notice it when checking. Then that's it. Let's proceed on the fourth case. Then after that, you can have the self-paced practice problems. Alright, so for the fourth problem, let's refer to the given. So according to the given, the car starts from rest. Okay, then we have final speed there. So of course, let's place v sub 0, which is 20 meters per second. I mean 0 meters per second, and the final velocity of 20 meters per second. And then we have a distance, which is 120 meters. So what is being asked? So this is the given. These are the given. So what is being asked or the required is the acceleration. Okay. So looking at your table or guide for the equations, the equation to be used for this is v squared is equal to v sub 0 squared plus 2a delta x. Okay, or you can place it inside the, what do you call this, radical sign. Okay, it's still the same. After all, you're going to square it again because what we need is acceleration. So let's do that. Okay, there. So let's operate on, or let's derive instead. So this is these terms are separated by addition. So that would enable us to transpose this to the other side. So this is negative v sub 0 to b squared is equal to 2a delta x. Then of course we want a to remain on this side because this is what we need, right? So divide both sides by first 2 and then by delta x. Then do that on the other side as well. So you're going to cancel delta x here, then you're going to cancel 2 here. So you're going to have a as the sole remaining variable here or term. Okay, so that would become a is equal to v squared minus v sub 0 squared over 2 delta x. Okay, so actually you can eliminate this one now, so you won't have very clunky solutions because you're going to notice this is 0. So let's do that. So for the solution, we have a is equal to v squared divided by 2 delta x. So a is equal to what's v? So this is 20 meters per second to b squared divided by 2 times 120 meters. Okay, so this is 400, correct, meters squared per second squared. Don't forget that. Okay, divided by 240 meters. Okay, can you see that? Alright, so after that, this is divided by 1, correct? So what's going to happen is you can input it on the cycle, but to show truly what would really happen, so this would be 400 meters squared per second squared. So this is divide, so you're going to reciprocal it, multiplied by 1 over 240 meters. So cancel meters here, cancel meters here. Always show the cancellation of the units. Okay, I really want to see what would happen to the units. Alright, so what's remaining? Meter per second squared, which is correct because the required or the one that we're looking for is acceleration, correct? So you can just input this on your cycle. So for the answer, that would be 400 divided by 240. Okay, not much else to do on the units because they're already in SI. So there, 400 divided by 20, correct, because this is on the denominator side. So what's the answer? 1.67. There, 1.67 meters per second squared. So this is A. There you go. See? There you go. It's really not that hard, right? So now you can proceed on answering the self-paced practice problems and work on your own.